Right, so for number 5, h is 0 because we would find it down here, added or subtracted to the x or from the x, and k is 2. A is negative, well, A is 1, but the negative is going to make cause a reflection over the x-axis. So we're going to take A as negative 1. So I'll put that right here. Nothing happens to x, and y gets minus y plus 2. So we transform those points. The x stays the same. The y, the opposite of y, which is 1 plus 2 gives you 3. The opposite, this stays the same. The opposite of 1 is negative 1 plus 2 is 1. The vertical asymptote is, since h is 0, it's x equals 0. Horizontal asymptote is your k value, y equals 2. Now we're going to graph. Alright, so we're going to draw the asymptotes first. So x equals 0. That's your vertical asymptote. And your horizontal asymptote is y equals 2. And so the negative 1, 3 is 1 point, and 1, 1 is the other. And that's all we need. We're gonna draw the 2 branches from the blue points going towards the asymptotes. And that one's done. Alright, so for this problem, h is 6 because that's right here. That's where h is. K is 0. There's nothing here. So this graph is going to move to the right 6 units. And that's the only transformation it's going to have. So that means that all the x's are increased by 6. Nothing happens to the y's. So negative 1 plus 6 is 5. Negative 1. 6 plus 1 is 7. And then the y doesn't change. The vertical asymptote is x equals 6. The horizontal asymptote is y equals 0. So draw the asymptotes first, x equals 6, and then y equals 0. Then we plot the points 5, negative 1, and 7, 1, and we draw the 2 branches from those points. So from this one we go out this way towards the asymptotes and towards the asymptotes. Alright, so this function is going to have 2 transformations, an h of 3 and a k of negative 1, which means that the function is going to move to the right 3 and down 1 unit. Okay, so that means the x's will be increased by 3 and the y's will be decreased by 1. Okay, because this is your h right here and this is your k right here. Remember, the h is the opposite because you're looking for what makes this 0, so what makes this 0 is positive 3. So a lot of students think of it as just taking the opposite of that sign. And the k, we do what it says minus 1, the graph is going to come down 1 unit. Okay, so now we're going to transform the points. So negative 1 plus 3 is 2, and negative 1 minus 1 is negative 2. 1 plus 3 is 4, 1 minus 1 is 0. Vertical asymptote is your h value, so x equals 3. Horizontal asymptote is your k value, so that's negative 1 minus 1. So first thing, the vertical asymptote, x equals 3. Horizontal asymptote, y equals negative 1. And plot the points, 2, negative 2, and 4, 0. And we use those points to draw our branches, our curves. So we go towards the asymptote and towards the asymptote. This. Alright, so this function is going to have 3 transformations. First off, it's the h value is negative 2, so it's going to move to the left 2 units. K is negative 4, so it's going to move down 4 units. And the negative is going to reflect it over the x-axis. Okay, so let's go ahead and transform the points. So the x is going to change by subtracting 2 from each coordinate of x. And the y, we take the opposite of y minus 4. So then the points become -3. And then the opposite of y, which is 1, minus 4 is -3. And then the other one, 1 minus 2 is -1. And then the opposite of 1 is -1. Minus 4 is -5. The vertical asymptote is your, you look at your h value at your denominator, so it would be -2. What makes that 0? And then the y value is simply the k value. Oops, sorry. Literally put it there. -4. So again, first thing we draw in are the asymptotes, so x equals -2 and y equals -4. Okay, and then the points are -3, -3, and -1, -5. So draw your branches using those points. Again, always going towards the asymptote. Whoops. And the other way. And the right side, the right branch, towards the asymptote. And there's your graph. Alright, so for number 9, f of x equals 2 over x. I gave you the transformed points right here, and I graphed it right here. So this is f of x. And I'm color coding it so that like the blue is the f of x. Now g of x is pink, and basically it's taking f of x plus 1. So then I wrote it here. So this notation right here means this. So I'm taking the blue graph and translating every point 1 unit up. So it'd be, oops, sorry, I forgot to change it. It'd be here. It would be something like this. That, and then instead of 1, 2, it'd be 1, 3. So it'd be like this, something like this. Now there would be an asymptote, because for f of x, the asymptote is on the x-axis, a horizontal one. But because k is 1 for the pink one, for the g of x function, it would be right here. And then the vertical would still be the same for both. Okay, so the yellow lines, the yellow asymptotes, those are for the pink graph for g of x, because everything got moved up 1 unit. Okay, so that's it. Alright, so for number 10, g of x is f of x minus 1, which means that the graph is being translated 1 unit to the right. So this is the notation for that, and this is how it would look with the actual function f of x. Okay, so that means that it's the blue graph translated to the right 1 unit. So the vertical asymptote, which was at y equals or x equals 0, is now going to move over 1 to the right, like that, and the horizontal stays where it is. It didn't move anywhere. And so the g of x function, again, take all the blue points and slide them over to the right 1 unit. So it'd be right here, and then just approaching the asymptote, and then the 1, 2 is now 2, 2 right here, and approaching the asymptotes. That's it. The pink one is the g of x, and the blue one is the f of x.